Okay, we're going. Just move that little thing out of the way. So, as we know, all induction proofs start with a base case, and that is for n equals 1. So we need to examine the statement here when the integer n takes a value 1, and so there we're looking at 2 to the power of 3 times 1 minus 1 is 7, yes, which is clearly divisible by 7. Okay, so we don't need any more justification there. So the base case for the induction proof is established. So now we make the induction hypothesis, which is that we assume that 7 divides 2 to the 3k minus 1 for an integer k greater than or equal to 1. And now we need to examine the follow-on case when n is equal to k plus 1. So I'm going to be considering, first of all, go back and erase that. Let's just spell out exactly what I'm assuming there. I'm assuming that 2 to the power of 3k minus 1, I'm assuming that it's equal to 7 times m for some integer m. That's what it means to be divisible by 7. Okay, so that's my induction hypothesis spelt out clearly then. So I'm considering the integer now 2 to the 3 times k plus 1 minus 1. Okay, and I can do some algebraic work on that. It's 2 to the power of 3k plus 3 minus 1. Okay, and now this is the hardest step in an induction proof. You've got to this middle stage, and you need to somehow make use of the assumption that you've made and prove the statement for the case n equals k plus 1. So the assumption I've made is this one here in the middle, that 2 to the power of 3k minus 1 is equal to 7 times m. I'm talking about divisibility, so that has to do with factorizations. So I somehow want to factorize this expression I have here and introduce this factor here, because this is the thing I've made the assumption about. So working on this, this is 8 times 2 to the 3k minus 1. Well, that's good. It's starting to look like my factor is appearing here. So really what I want is I want to have an expression where I have this factor and some other stuff. So I'm going to need an 8 in front. Give me my 8 times 2 to the 3k. But this equation isn't fully right yet. The discrepancy is 7. On the top line I've only got minus 1. On the second line here I've got minus 8, so I need to add on an extra 7 in order to complete the equality. Okay, this doesn't really need any justification, it's just algebraic manipulation. But here is where I bring in the assumption that I've made, because I assume that 2 to the 3k minus 1 is equal to 7m. So this here is true by assumption, and this can now be written as 7 times 8m plus 1, i.e. it's divisible by 7. Okay, so at this point I'd review that, talk about how we've applied the principle of induction here, and I suppose the proof would finish off by invoking the principle of induction. So the result is true for all n greater than or equal to 1 by the principle of induction. Okay.